Hey guys, let's look at the graphs of sine and cosine. This is a pretty long section and it's pretty important, and it's really the main thing I want to concentrate on for this module. When we first define sine and cosine, we define them as ratios of the sides of right triangles. Then we sort of expanded that to the unit circle so that we could look at the sines and cosines of angles that weren't strictly between 0 and 90. And now we're going to look at graphing like sine of t and cosine of t as a function in the xy plane. So let's do that. It's going to come straight from the unit circle. Let's look at a point here. Recall that if you've got a point on the unit circle, if you call the angle t, then the x and y coordinates of this are going to be cosine t and sine t. So what I want to do is think about what happens when this moves around the circle. Now, you might be familiar with this already, or at least somewhat. Maybe you've seen before what sine and cosine waves look like. So I want to show you where that comes from. Let's look at sine first. So I'm going to graph it down here on this. This is my t-axis, and this is y. So what I'm going to do is for each angle starting here at 0 and then moving around the circle, what I want to do is I want to plot the value for y. I want to plot that as the sine value. So let's look at these points. Here at the beginning, you've got t is 0, and the y coordinate of this point is also 0. So down here, I'm going to plot 0, 0. Up here, t is pi over 2, and the y coordinate there is 1. So I'm going to plot that here at pi over 2 and y coordinate of 1. Now over here, now t is pi, and the y coordinate is 0 again. So I'm going to come over here to pi, let's see, pi, and I'm going to plot the point at 0. Then down here at 3 pi over 2, t is 3 pi over 2, and the y coordinate there is negative 1. So I'll come over here to 3 pi over 2, and I'll plot negative 1. Then when we come back up to this point again, I mean, it's the same point, so y is still 0, but we've got t is 2 pi. And so we get these 4 points, or 5 points. And I can connect these with the smooth curve. Let me try that again. Connect these with the smooth curve, and I get this shape, which is one period of the sine wave. Now, if I let this continue to go around, it'll just continue and make another sine wave over here. And if I had started further back, or if I start here and go backward, it makes another wave back here. So that's where the sine wave comes from. Now, if we do cosine, I'm going to do cosine quickly. We would just look at the x coordinates of these points around here as we go around the circle. So this first one would have an x coordinate of, see, the x coordinate there is 1. Up here at pi over 2, the x coordinate is 0. Over here, the x coordinate's negative 1 and then 0 again. So negative 1 at pi, 0 at 3 pi over 2. And when we get back over here, the x coordinate's 1 again. That's here. So the cosine curve, it's the exact same shape, but it starts up at 1 instead of down at 0. So sine and cosine both come from straight off the unit circle. Now, that's not a great drawing. I made a little animation that I want to show you. Let's see, if I switch over to here, this is my web page. I can't quite see it on here. Here we go. This thing at the bottom where it says sine wave animation. This is a nice animation of a sine wave. And notice the point is moving around the circle, and I'm tracing out the x, the y coordinate, and that's what's giving us this this nice sine wave over here. I've got two sliders here. One of them is for adjusting the speed. So if I speed it up, I get a tighter wave. I guess the technical way to say that would be it gets a higher frequency or a shorter wavelength. If I slow it down, then that makes the wavelength longer, or the frequency lower frequency. So anyway, I wanted to do that just to just so that we can see a nice animation and see where the unit circle and the sine wave are related to each other. Now, one thing I also want to show you here is this is just tracing around from one circle. If I add some circles to it, let me just add one there, and it's a little fiddly trying to get the just one circle. There we go. So as this goes around, notice what's going on. Really what's happening there is we're adding a couple of sine waves together and we're getting this more complicated pattern. If I add a few more, the pattern gets more complicated. If I add a bunch of these on there, we get something that's approximating a square wave. It turns out by adding sine waves together, we can get any sort of wave we want out of this. This is kind of a teaser for a topic called Fourier series. And that's normally not something that's taught in pre-calculus, but we're probably going to talk about it a little bit later on just because it's really cool. It has a lot of applications, especially like with synthesizers and music. And we'll talk about that later on. But for now, I really just wanted to show you, this is where the sine wave comes from, where the graph comes from. All right. Let's see. I want to talk about this other stuff, but I'm going to put that in the next video.